Hello, everyone. Thank you for coming today. I'm Jade. This is the Cloud Native Valencia team. Yeah, basically, I think I won't spend so much time doing introductions because this is the third time that we are doing this event. But basically, we try to do events each quarter or each 3 months. We try to do the event, and then of course, we discuss about topics related to the cloud native ecosystem, open source, community. It doesn't need to be only a technical topic. If you have something correlated to open source culture, is it a good topic for us too? I just wanted to show you quickly this. This is where you can find us. Please follow us, and if you can put a review, of course, if you like the event, if you like the organization, put a review in Meetup. It's pretty important for the community. What else? Of course, I want to say thank you to Diana. Diana is our speaker today, and it's also sponsoring our event with VictoriaMetrics. Without sponsors, we cannot do this, basically. And let's see. Some nice updates. Discount code for Linux Foundation exams. If you want, we have the discount code here. And then at the end of this meetup, we'll have a raffle with Chad's book. And we also have a table of swags and stickers here. Please get yours. And the VictoriaMetrics swags too. I think we can start. Bernardo.
This is supposed to be a party, right?
Yeah.
10 years of the CNCF. We are not going to force you to use, birthday.
Yeah.
If you want to, just.
But these are pretty cool if you want to get yours.
Yeah. So I guess it's almost 7 p.m. We can get started. The first presenter is Rael and Anna from UV. They're going to talk about the incubator at the UV. You guys can come over and start. Thank you.
We're going to do the presentations, and between each presentation, we'll have some calls to go do some networking, and eat food and drink, and get back. And at the end, we want to have cake for the party.
Cake. Thanks, guys. Thank you.
Bueno, buenas noches con todos. Mi nombre es Israel y mi compañera Ana. Hemos hecho la presentación en castellano. Nos dijeron que podía ser nuestra decisión, así que les vamos a presentar acerca de la incubadora en la cual nosotros estamos vinculados. Es una incubadora llamada IATecUV. Esta incubadora forma parte fue promovida por la Universidad de Valencia y el Parque Científico de la Universidad de Valencia, que es donde nosotros estamos trabajando con mi compañera. Este es un ecosistema donde se alojan actualmente 100 empresas de todos los sectores, pero la incubadora, que ahora mismo vamos a contarles todos los detalles, se dirige a la inteligencia artificial y a las tecnologías habilitadoras. El objetivo que tenemos con esta incubadora es aumentar la transferencia de conocimiento entre la universidad y el tejido empresarial. Es decir, que los estudiantes que egresan o salen de la universidad puedan vincularse a la empresa o puedan tener ya una relación laboral estable. Otra es impulsar la creación y consolidación de startups o spin-offs digitales intensivas de investigación y desarrollo, potenciar la competitividad, y esto con el objetivo de generar un impacto, no solamente en la región, sino también en un contexto nacional e internacional. Y también dinamizar la innovación abierta. Esta incubadora tiene un enfoque sectorial, es decir, si bien va en relación con la inteligencia artificial y las tecnologías habilitadoras, queremos abarcar también otros sectores, todos los sectores. Excelencia científica tecnológica, relación constante con las empresas y generar sinergia en la realidad, ¿no? Que los estudiantes puedan formar parte de una comunidad y que las empresas que se vinculen a este proyecto puedan relacionarse entre sí y también conocer a otras empresas que se dedican a lo mismo. La comunidad está formada realmente por startups, spin-offs, grupos de investigación, empresas tractoras, todo tipo de empresas y buscamos tener un hub de referencia internacional en tecnologías habilitadoras de inteligencia artificial. Ya hemos lanzado una primera convocatoria. La primera convocatoria cerró el mes pasado y consiste en un premio o en una financiación de 4.500 euros, que la lanzaremos una vez por año. El premio consiste en 2.000 euros en apoyo económico directo y 2.500 en bonos de servicios para hacer uso de las instalaciones del parque científico.
Os voy a explicar yo un poco cómo funciona el programa de incubación que tenemos en IATecUV. Principalmente es un programa de mentorización para startups. La mentorización puede ser tanto empresarial como científico-tecnológica, porque entendemos que muchas veces las startups están fundadas por gente experta en el tema de la digitalización, pero les falta esa parte o echan de menos esa parte empresarial que muchas veces incluso llega a ser un obstáculo para meterse en este mundo empresarial. Entonces, podemos darle tanto mentorización empresarial como científico-tecnológica para si necesitan apoyo en el desarrollo de su propio proyecto. Parte de la mentorización empresarial ya no solo es una mentorización personalizada e individualizada a cada proyecto, sino que también realizamos una formación intensiva teórico-práctica, que nosotros hemos llamado Bootcamp, porque nos gusta ponerle nombre a todas las actividades, y consiste en una formación de 2 días y medio muy intensivas en las que reunimos a todas las empresas. Es una manera también de que entre ellas se conozcan, hablamos de embudos de venta, de mercados, de cómo hablar con inversores, cómo presentar tu empresa a diferentes personas. Todo esto forma parte de la formación y entra dentro de la mentorización empresarial. Luego también ofrecemos instalaciones propias, como os contaré enseguida, estamos en el Parc Científic y tenemos un proyecto de creación de ampliación de uno de los edificios que tenemos actualmente. Pero además de eso, también tenemos salas de reuniones, diferentes salas donde poder llevar a cabo las actividades de las diferentes startups. Por otro lado, facilitamos networking, acceso a socios y financiadores a través de esta comunidad IATecUV que hemos llamado, que como ha dicho Israel, es este ecosistema innovador en el que confluyen las startups incubadas, las empresas tractoras referentes del sector, entidades colaboradoras, y ahora estamos intentando también incorporar inversores y financiadores. Y finalmente, otra de las ventajas del programa de incubación de IATecUV es el acceso a servicios científico-técnicos de la Universidad de Valencia, como por ejemplo, acceso preferente a los servicios de la red de supercomputación española, que ofrecen servicios de supercomputación, de inteligencia artificial y de gestión de datos. Por otra parte, acceso preferente a Artemisa, que es una granja de servidores que se encuentra en el mismo Parc Científic y tiene servicios dirigidos a empresas. Conexión con las incubadoras europeas, ya que nosotros formamos parte de este grupo, de este ecosistema. Y por último, un servicio que es el SDIE, que es mucho más dirigido a empresas que aplican a sectores de microscopía, de física, de imagen. Entonces, esto también está a disposición de las startups y forma parte de la Universidad de Valencia. Por poneros un poco en contexto de lo que sería la cronología de cómo funcionan estas actividades, IATecUV inició en la primera mitad del 2024. Es verdad que no hemos empezado la primera convocatoria hasta octubre de este año, porque todo este tiempo lo hemos utilizado para ponerlo a punto, para crear el programa de incubación, buscar al equipo, a los asesores, la marca, todo. Luego acabamos de lanzar la primera convocatoria que, como ha dicho Israel, ha cerrado ahora en octubre y ahora mismo nos encontramos en la selección de proyectos, ya que solo seleccionamos un máximo de 10 proyectos por año. Porque ahora mismo, por el tamaño que tiene el equipo, como queremos dar una mentorización personalizada y individualizada, si queremos dar calidad, no podemos coger a más empresas. Al principio de año siempre nos reunimos, es como el inicio del programa, nos reunimos con las empresas, vemos cuáles son sus necesidades, marcamos objetivos y ya les ayudamos a empezar este camino con nosotros. Alrededor de febrero o marzo realizamos lo que he llamado antes el bootcamp, que es esta formación teórico-práctica intensiva, Y alrededor de marzo, un poquito antes de la mitad del año, hacemos una presentación de esas 3 startups. Esta presentación está sobre todo dirigida a la comunidad, a todas estas empresas tractoras, a los inversores, pero está abierto a cualquier persona que estuviese interesado en las empresas. Luego, durante todo el año, estamos con ellas y las acompañamos y alrededor de septiembre-octubre abriremos la segunda convocatoria. Esa es la idea, es algo que queremos repetir anualmente. Las empresas que sean seleccionadas pueden estar hasta 3 años con nosotros, aunque cada año cogemos 10 empresas más. Y repetiríamos el mismo esquema. Una vez terminaríamos la segunda convocatoria, haríamos la selección de estas 10 y empezaríamos con el proyecto, que nos reuniríamos con las que quieren continuar con nosotros, más las 10 nuevas. Y algo destacable del 2027 es que a mitad de año ya tendremos las instalaciones finalizadas para todas aquellas empresas que quieran un espacio. No es obligatorio, pero sí que aquellas que quieran tener un espacio en el Parc Científic pueden solicitarlo. Todo esto, como os he dicho, ocurre en el Parc Científic, no sé si lo conocéis, se encuentra en Paterna, muy cerca del Parque Tecnológico, y es un ecosistema donde puedes encontrar desde empresas, institutos de investigación, parte de universidad, grupos de investigación, startups, pymes, empresas grandes. Entonces, todo esto ayuda a que se crean sinergias, colaboraciones y sea un ecosistema totalmente innovador. Y con esto, daros muchas gracias por la atención y si tenéis alguna pregunta, nosotros estaremos tanto ahora como luego en el network.
Yes.
Hi guys, good evening. I can do Spanish. I can do Italian with some extra S if you want. Not sure if I don't think that's going to be very useful. But I'm very happy to be here in Valencia. I'm here on holiday for a couple of days, so I thought it was a nice opportunity to meet the local Valencian community. My name is Andrea. I'm originally Italian, based in Amsterdam, and I work as an independent cloud native consultant, engineers, platform engineer, DevOps, call it whatever you want. I do things with the cloud. Let's put it so. One of my clients is based in Amsterdam. It's called Uberstory. It's a startup I've been working for a couple of years now, and they have a very interesting use case related to Kubernetes, Cloud Native, and wildfires, which is pretty, it's something that is different from the usual use case that we have for AI because it involves something very destructive, which is wildfires. It's something we don't often think about. There's some images from a wildfire that happened earlier this year in the area of Los Angeles. Very destructive wildfire. Many, family, businesses, and communities have been destroyed and been affected by this one. So it was one of the largest wildfires that ever happened in California. And just to give you a couple of numbers here, over 29 people died, over 200,000 people got evacuated, 18,000 homes destroyed, and over 57,000 acres of land got burned down. Just to represent this in an image, if you put it on top of Valencia, this is the corresponding area of 27,000 acres. So basically the whole city of Valencia and a couple of the surrounding provinces completely burned to the ground. And this, you might be surprised to know, and I didn't even know that before joining our story, this is not even the most destructive wildfire that California ever experienced. In fact, back in 2018, the Kent wildfire burned 3 times as much area. And another thing that I didn't know is that in California in particular, over 60% of the most destructive wildfires have been caused by defective power grids. This is a problem, especially in the US, is more present compared to Europe. In Europe, our power lines underground mostly. So the cause of wildfire that you have in Spain, Portugal, Greece, or Italy as well are mostly related to some other problems. But, in the US in particular, since they have the power lines above ground, many of the wildfires that happen over there are caused by defective power lines, by power network that is not maintained in the right way. And power lines is a complex system, and especially preventing wildfires that are caused by defective power lines is a very complex task. We have plenty of systems to contain wildfires once they spread out. So once that wildfire is spread out, we have plenty of techniques to contain it and make it, this radius as small as possible, but preventing wildfire is extremely difficult to do for a couple of reasons. The first one, power lines are a complex system. A power line is anything between a power station and the plug that you use to charge your laptop. It's composed of like major station, substation, smaller station, high tension lines, low tension lines, underground lines, above ground lines. And they bring electricity to our systems, to our house and businesses 365 days per year. If you think about hospitals need electricity basically in an uninterrupted fashion. Failures in power lines are very often sudden and catastrophic. This is another example from earlier this year. Back in April, a power substation blew up, basically took fire in the Heathrow Airport of London. This caused the Heathrow Airport to be shut down for 24 hours, meaning over 1,000 flights were disrupted and 300,000 passengers was affected. And I'm talking about one power substation of one airport. Finally, all our infrastructure is subject to atmospheric agents. This means that heat, cold, hail, wind are all things that can affect how the electricity goes from the power station to our homes. The atmospheric agent can damage our power lines and they can damage the infrastructure. And inspecting those power lines for maintenance or for problems is not as easy. In the US in particular, the majority of the work that we do at Overstory is with US customers. Sometimes those power lines, they cross private property. This means that you need to get the authorization of the owner of the property to go and inspect the power lines. These extremely time-consuming, very difficult, and very expensive. So with Overstory, we take a bit of a different approach. So instead of inspecting the power lines from ground, we try to do the same work, but from the sky. So we use satellite images, in particular, a combination of high-resolution satellite images and aerial images to inspect the power lines from the sky. Meaning that we look at where power lines are passing, we look at the vegetation surrounding it, and basically we give to the providers, to the energy provider, a risk score. Basically, we tell them what is the likelihood that there is going to be a wildfire in that area in the future. So they can go and clean the vegetation before a wildfire spreads out. It's a very complex system. It's a very complex, thing to do, especially when you deal with nature. There's a lot of things that are very difficult to predict. Let's put it this way. But just to give you an idea, I try to simplify the whole process, which takes like weeks and months of work in 3 steps. Let's see how I do. The first thing we do is that we collect vegetation data. Meaning that we get satellite images from different providers like Maxar, Sentinel, and so on. We get different resolutions, we get different types of scan, and this helps us to detect things like which trees are in the area, what is their height, what is the condition of the ground, and so on. Different trees grow at different paces. The weather condition as well influences how fast the tree can grow and where it's positioned on the map. We then combine this information with other information that we get from the electricity provider, meaning that they give us a very detailed map of every pole and line that they have. They tell us where the poles are, where the lines are they high tension line, high voltage line, or low voltage line, how tall are they, and so on. And by combining these two information using some algorithm that we have developed over years now, we managed to get them a risk score, meaning that for each piece of their power line infrastructure, they get to see what is the wildfire risk in that specific piece. In this way, what they do is that they can go and clean the vegetation before a wildfire spreads out. This has been an ongoing work together with the energy company. It's a work that is recurring. It happens every year, pretty much. So we even scan their network year after year. And they, of course, verify that our results are accurate. How did we do that? Well, we got started some years ago. I've been starting to work with Overstory back at the end of 2020, but then we were a startup of around 20 people. And when we got started very, very soon. We started using Kubernetes because it was giving us the right flexibility. We sometimes need an algorithm that use a few CPUs and a few gigs of memory. And sometimes we have algorithms that can saturate 75 core machines for a day. And we use Jupyter Hub. I'm sure all of you familiar with Jupyter Notebooks, more or less. It's basically an interactive way of running Python. Let's put it this way. We needed to iterate very fast, break things. It's a startup. We didn't have product market fit back then. So we were just going really fast and breaking things using Jupyter Hub. So Kubernetes together with Jupyter Hub for us was all we had. Basically, our data scientists, they could select the container image that they wanted with all the libraries that they needed, select the machine that they wanted, depending on the algorithm they needed to run, and then they would just run their experiment inside Jupyter. As simple as that. But, as you can imagine, this does not scale very well. Overstory scale was more employees, more people, more customers, more scans to do, and this system was just not scalable enough. Passing to each other like Jupyter Notebooks or Slack was like a daily thing, and these kind of questions were also very common. Which Python library did we use a year ago to run the scan? Which machine did we use for this particular Python notebook? It was impossible to repeat the scan. Basically, repeating the same scan that we did like a year before was like a full-time job for like 2 weeks. Very, very complicated, very manual process, and very difficult to reproduce. This is why we decided at a certain stage that it was time to automate, time to change things and make things a little bit more repeatable and more scalable. For a company, it was growing pretty fast in terms of like employees, but also customers and clients. First thing, we decided we wanted to get rid of Jupyter Notebook. And this was like, godsend for me, because they were extremely difficult to maintain, very difficult to test, and tracking them in Git was just a nightmare. And we wanted as well to automate our workflow runs. Back then, we would basically assign one full-time employee for every client that we had. And that person would take care of that client exclusively, basically full-time. This scales well if you have 4 or 5 clients, maybe 10. When you start to have like 20, 30 clients, things get a little bit more. So we decided we needed data, a workflow orchestrator would basically be able to do this processing in an automated fashion. We landed on a tool. Called Dagster. It's open source software. It's developed by a company in the US. I personally like it very much as a cloud native engineer, more than a data engineer. But I would say that also our engineers like it a lot. It's open source, as I was saying, it allows you to iterate really fast, very fast development, even locally. It's very easy to test, and it's basically Python, which is something that our developers like no longer. On my side, as a cloud native engineer, I like it because I feel like it's one of those tools that is really built with cloud native in mind. If you look at its infrastructure, I'm sure you're all familiar with this kind of like arrows and boxes. This is pretty much a microservice architecture, meaning that each one of our team is responsible for a set of pipelines, for a set of data, and each one of them can deploy independently. So every team is responsible for a set of pipelines and a set of data. Each one of these pipelines and data is stored in a repository, and whenever a new team updates these pipelines, all the other teams are unaffected. It's not one big monolith that breaks as soon as somebody pushes something at some tool that is broken. And so our users are able to interact with it using this nice web interface. The daemon takes care of scheduling the runs whenever they need to be scheduled in response to, every day at midnight, or in response to a certain event, for example, a new satellite image landing in our cloud storage. And all our developers, all they do is basically create new pipelines using a normal like CI/CD workflow. And so they make new releases, they try to stage, whenever they're confident what they've done, they can make it work in production. Another thing that I really love about Dagster is the idea of IO manager. If you've used other workflow orchestrator, it's very common in your code to have all kinds of ifs that says, if I'm running this locally, you need to save it in my local file system. If I'm running this in the cloud, you need to save it to S3. If I'm running this on Google Cloud, you need to save it to GCS. This doesn't happen with Dagster. Dagster is a framework that allows you to deploy and to modify and to build the pipeline independently from the platform where you're running. Meaning that your code does not change, but if you're running it on your local Docker daemon, it will save file locally. If you're running it in Kubernetes, it will save the file whenever you want it to save it. You don't need to code that logic inside your pipeline. Your Python code stays just the data flow and the data orchestration stuff. And that's another point that Daxter got really well a couple of years ago. It was one of the first one that got this right, in my opinion, and now other tools like Airflow got it as well in the new major version, Airflow 3, I believe. In the past, data meant a couple of things. It was either a file or a database, pretty much, in the old, when we were not using the cloud. So, you had a limited number of connections, you had a limited number of relationships. But when you work in the cloud, data can mean a lot of stuff. Data can be a BigQuery table, a Snowflake table, your DLT ingestion pipeline, a file in Google Cloud Storage, or your PostgreSQL database. And finding out the relationship between these files, finding out the relationship between this data becomes more and more difficult. And so Daxter took an approach that is different from other workflow orchestrators some years ago. And instead of focusing on how data is built, it focuses more on how data is related to each other. So in the Daxter interface, what you see is how data is related to each other. And it doesn't matter if the data is a BigQuery table or a file in GCS. What Daxter highlights is how the data flows. So in here, you can see very clearly which data relates to each other and which data you need to refresh whenever something else changes. So for example, in here, this Chewy DBT project, and I know that this DBT project needs to be refreshed whenever one of these two changes. Then this DBT project can be in BigQuery on a DACDB file. It doesn't really matter. The nice part about Daxter is it shows you how data is connected with each other, not so much how data is built. The way that you see how the data is built is in the code. The web interface highlights how the data is related to each other. Over time, we started building as well our own tools. We started using Daxter more and more. We started finding out, its little quirks and problems. It was still a young product back then, so even contributing that to the open source project was something that we were doing on a regular basis. But we also started building our own pipelines and our own libraries. We created a library that we call Maple. At Overstory, we have this tradition of calling things with the name of trees. So our clusters are named Elm, and our library is named Maple. And basically what we can do now is that for some of the Python functions that we have, we can specify exactly how much CPU and memory that function should use, and that function should reserve. So for example, I can say that this particular Python function needs at least 32 CPUs and at least 390 gigs of memory. And Kubernetes and Daxter will schedule it on a node that has at least 32 CPUs available and at least 390 gigs of memory available, which is a pretty nice thing. It's a pretty nice thing because it makes iteration for our developers much, much easier. And I can do that for anything. So I can do that with CPU, memory, scratch disk, GFS volume, GPUs. Everything is contained within this Maple library that we built over time. In the future, I would love Maple to be even more, to show even less of the Kubernetes internal. Unfortunately, we're not there yet. But ideally, in the future, our developers will have to play, not to focus so much on node selector and just have to specify what they need precisely. I would love them to be even less aware that Kubernetes is there. One nice thing about Daxter is that it allows to also do things in two different ways, meaning that you can either have a pipeline that is sort of like constant in terms of usage of CPU and memory, or a pipeline where, for example, your CPU and memory usage shifts, where maybe you need different types of resources during the pipeline. In the first case, what you can do is that you can run the whole pipeline inside the same pod, meaning that your pipeline takes on average 4 CPUs and 8 gigs of memory. All the steps will run as part of the same pipeline. Or what you can do is that for each step of the pipeline, you can assign different resources. Because maybe, your pipeline might be 12 hours long, but you need a GPU only for 1 hour. You don't want to pay the GPU for 12 hours. You want to pay only for the hour you need. And so what Daxter allows you to do is to have multiple pods during the duration of your pipeline. Meaning that the first one can require, for example, some CPUs. The second step maybe needs a GPU, and then the third one needs the kernel storage. You don't need to reserve them for the whole pipeline. You can reserve them for the individual steps. Now, connecting all the pieces, taking all the pieces all together. This is a screenshot I took back in March. Back then, for the first time, after a lot of work, we managed to redo a scan that we did previously, end-to-end, no touch, meaning there was no human interaction. We didn't do any manual processing. We didn't need to do any weird Jupyter Hub stuff. This was a major success and the first time that we managed to do it. This was back in March this year. We were running on average 27,000 jobs a week with a success rate of 95.9%. And this was another screenshot they took not a month ago, but back in September. And at this point, we were running 27,000 jobs a day with a success rate of 98.3%. So it was a great improvement and also gives an idea of how much Overstory has grown over the past year alone. The number of customers that we have has grown a lot. Over time, we also this kind of relationship of trust, where basically in the beginning, they give us a small area to scan. The second year, a larger area. And the third year, we had a larger area. So this year, we really had some big customers with a lot of area to scan, which was a very interesting challenge as well from the infrastructure. What is next for us? Well, the first thing is always to deliver results as hands-off as possible. This is extremely difficult, especially when you deal with nature, with satellite images. Seems stupid, but something I didn't know as well, or at least I didn't think about before joining the story. If you need a satellite image of a certain area, and that day is particularly cloudy, the only thing you can do is wait. There is nothing else you can do. So sometimes when you work with tight deadlines, because maybe you promise your customer to would give them the result within a week or two, sometimes you might just wait 3 days because the satellite images are not available. We would like to break a little bit this one step, one node, or one job, one node assumption and move our developers as far away as possible from knowing Kubernetes and the intricacies of Kubernetes. This is something that we got in an okay-ish way with Maple version 1. We would definitely like to improve it with Maple version 2. And this is also another problem that we very much have, avoiding under-provisioning or over-provisioning resources. The problem with under-provisioning means that our developers reserve less CPU and memory than what they use, is that they might have a pipeline that is 12 hours long, and it fails at the 10-hour mark. And if they haven't put it properly, it means they need to do the whole thing from scratch, which is a huge waste of time and money. Over-provisioning, the pipeline works, it runs until the end, but we're wasting resources and we're wasting money. This is also a very interesting challenge. We've been working a lot over the past year over monitoring. The thing is, in our use case, depending on the input images that we get and the parameter that we give to the pipeline, it might take very different amount of CPUs and memory. So it's not as easy for us to predict how much CPU and memory a certain pipeline is going to use before the pipeline gets through. But we're working on that. And yeah, these 3 steps is what we're going to work in 2026. Next year, we just got a new round of investment. So next year is going to be even bigger than this year. It's going to be very interesting. And so we will see what we can do. But yeah, it's a very interesting challenge. It's a very interesting use case for AI. And yeah, I invite you as well to check out the website of the story in case you're interested. Thank you very much. Any questions? Mostly the US. Mostly the US due to the fact that most of the lines are above ground. The thing with the US, like Europe, is very densely populated, if you think about it, compared to the US. The US, there are certain areas where power lines are crossing, like areas where nobody goes for a decade. So maybe there is like a power line hanging and nobody notices. Since Europe is a lot more densely populated, this problem, we don't have this problem as much compared to the US.
Thank you. Yeah. You rely just on satellite imagery, or do you have aerial inspection of power lines in the US? Small planes flying very low.
Yeah, we do a combination of the two. Aerial images and satellite images, a combination of the two. Sometimes you also different types of scans. So satellite images, maybe you mostly get colors. with the aerial images, you can also do like infrared scans and this kind of thing. So we combine information. It depends on the area. We don't do it for everything, but whenever it's needed or our model maybe is not 100% accurate, we can compensate satellite images with aerial images.
And so out of curiosity, is that a situation where you can request them, or you just are a consumer of other people's generated data?
It depends. Like even in the US, like every state has its own, regulation and thing. We need to interact with a lot of like public entities as well. So it's not always, every state has its own regulation. But yeah, for satellite images, I'm 100% sure that we request them. So basically, you give them the coordinates that you want. You wait an X amount of time, and then you get the image back. For aerial images, I'm not 100% sure.
Regarding the pipeline, how you calculate the memory and CPU that you need for new pilots?
For a new one.
For new one.
We run it a couple of times and we check the monitor.
Okay.
Yeah, at the beginning, the process is we brute force it pretty much. Let's put it this way. We try always to give it images that are of a regular size or constant size, but that's not always possible. The thing is that even the parameters that you tune within a pipeline can influence a lot the memory and CPU usage. So that's a very complicated problem that we haven't really managed to fix fully.
How do you store the data in pods pipeline?
This is a good question. Yeah, sorry, I haven't figured the question until now, but I got asked, how do you store the data between pipelines that are multiple steps, where every step can run a different node? It's an excellent question. With Dexter, what Dexter is going to do is that whenever one step ends, it will upload the data on GCS, we have on Google Cloud, and then the next step will download that data and process it again, no matter how many steps you have. That's another nice thing of Dexter. You don't need to code it yourself. If you run it locally, it will be a local file. If you run it in the cloud, it's going to be a file. Yeah.
So we got to the point where we're looking at specializing the hardware selection and things like that to optimize the compute, things like that, or is it kind of a generic provision for the next?
In terms of like GPUs, you mean?
GPUs, or is it ARM versus x86 or things like that? Does that have any impact on that?
Yeah, it does. So we don't use ARM a lot. The thing is that many of the libraries that we use are like are Python libraries with C++ bindings. So, you can get into all sort of like black magic and you don't want to play. Not all the libraries are compatible with ARM, so we use mostly x86. In terms of GPUs, we have been using mostly P100 Tesla until now, or A100. We are currently moving away towards, we haven't decided yet. The thing is that GPUs have been really scarce. Like, we are based in the Netherlands, and I got so many times the message, Google Computer Engine is out of resources. Like, they could not allocate more GPUs for us. So we've been working together with the folks at Google, so that instead of fixing on one particular GPUs, we can choose between like 3 or 4 of them. And they will just give us whatever is available kind of situation. Yeah, we have been working towards that because we found ourselves a little bit bottleneck, especially this summer, where there's not enough GPUs. It's great. Okay. Thank you very much. I will join.
All right, I'm going to introduce our next speaker. Here's Diana. She's from VictoriaMetrics. VictoriaMetrics, thank you again for sponsoring this for this meetup. And we're going to be talking about open source cloud native observability with VictoriaMetrics and OpenTelemetry. So I'll pass it over to you.
Yep. Cool. Thank you, Chad. First of all, thank you very much for being here, guys. It's really awesome. I've been to the second meetup at Cloud Valencia, and I already see like a lot more faces. So that's really, really good. Also, a big thank you to the organizers. It's not an easy task to put this together, and actually it's a lot of effort. So a round of applause for the organizers. Yeah, so let's get into it. Yeah. So my name is Dana. I live here in Valencia for the last 4 years almost. Previously, I've been living in Barcelona for the last 6 years. So altogether, 10 years in Spain. I know Spanish, so you can ask me any questions if you want in Spanish. Yeah. Okay. Yeah, I'm nervous. No, it's okay. Yeah, I'm originally from Romania, Bucharest. I'm a Cloud Native Days Romania organizers. We are opening our CFP next week. So if you want to apply, please do so. You have like 2 months to wrap it up. Send it to us. We're going to host it from 18th to 19th of May in Bucharest, and that's the capital. And yeah, we're welcoming you there with nice food and nice weather. I'm an OpenTelemetry member and contributor since last year. And I'm going to be speaking about OpenTelemetry today as well. And co-lead of neurodiversity group, part of Merge Forward cTENcf initiative. I know that's a mouthful. Actually, Merge Forward is a very new initiative that groups all the underrepresented, let's say, initiatives in cTENcf. Neurodiversity being one of them, but it's also like women in clouds and other interesting initiatives. So anyway, if you have any questions, curiosities, if you want to join, please let me know and we can discuss about that. Also, the slides for this presentation and previous presentations that I did are on my GitHub repo, so you can download them and also listen to the videos if you're interested. Okay. Perfect. So I wanted to do this a bit differently because I have time to like fully explore this. And I wanted to start with: do you know what VictoriaMetrics is, or heard about it, or use it? I know. Yes. Okay. Cool. Yeah, that's good. Well, we heard about this stuff like so many times from our users. So what VictoriaMetrics isn't is not a fork of Prometheus cTENcf project. It's not named after Queen Victoria or whatever, Victoria, British Columbia. That was new for me too. It's not just a front-end visualization tool, just like, Grafana or whatever, that runs ClickHouse or Thanos in the backend. So we just run ourselves, right? So it's VictoriaMetrics with VictoriaMetrics done underneath it, basically. So boom, there we go. That's not correct. VictoriaMetrics right now forms an observability stack because besides metrics, we provide logs as well, which is in production since last year. Right now under development is traces for distributed tracing. It's still not in production, so it's under development. It's going to soon be released in production. But all these are open source, right? So definitely open source, available on GitHub. We have benchmarks that I'm going to explore later. So yeah, be curious and go for it. Also, besides the open source part, you would probably wonder how VictoriaMetrics makes money or how does it survive? Well, basically, it sells enterprise support, right? So the only thing that actually keeps VictoriaMetrics alive alive money-wise, is actually with the help of enterprise support, right? For the companies that need it. We also available on-premise and clouds, and we are Kubernetes and OpenTelemetry compatible, which is really cool. And you're probably wondering about that sustainability thing. Actually, that's a very nice correlation because VictoriaMetrics is, let's say, focused on a sustainable mission since its day one, and we're going to see that. I'm going to talk about the benchmarks. Also, since 2023, VictoriaMetrics is a cTENcf Silver member. So yeah, we are definitely, let's say, attuned, like another thing, like in sync with the cTENcf principles, and we are supporting cTENcf as much as possible. Right. So I wanted to start with this one because I was having a chat with Roman, one of the co-founders, and he let me know, look, if you're giving this talk, just mention how VictoriaMetrics started. Because it's a very small company and not many people know about it. VictoriaMetrics started in 2018 in Kiev, in Ukraine, and it's open source. And right now, we have around 53 employees. We are all distributed around the world, and that's a really cool thing. Actually, at the beginning, VictoriaMetrics wasn't open source. The co-founders had this like really cool idea, and they wanted to sell VictoriaMetrics as a SaaS product, right? That was a really bad move because nobody, if you're coming on a market that's already really saturated on specific observability vendors, like products, if you're going to try to do this from the beginning with no backup, no investors, and basically no publicity, nobody's going to try it. So instead, they focused on open sourcing it. So definitely they went after 5-6 months, they open sourced it. And they focused only to create very good products that everybody would use. They'll be interested to use it and contribute and make it better. So that was like, after the first lesson, that was a very hard lesson. They decided to definitely go for it as an open source project. Many people are wondering right now, for example, with any other open source project, but what makes you, how do we know if you're going to stay on the market as open source or if you're going to just sell it at some point or close it or whatever is going to happen? Look at Terraform, for example. Well, the idea here about VictoriaMetrics is not investor-led, so nobody will force VictoriaMetrics at some point to close it. So there's no obligation to close the open source project. You can check this talk. Actually, it's pretty genuine talk given by Roman, and he goes in depth with the beginnings of VictoriaMetrics and other cool stuff about it. Right. So VictoriaMetrics, we definitely contribute to a lot of open source projects and Cloud Native cTENcf other projects. Basically, everything started with Prometheus. This is how VictoriaMetrics actually, got its ideas to optimize Prometheus due to its scalability and efficiency limitations. And they figure out that at some point people will find out about these limitations. So they came forward, they got together and they formed VictoriaMetrics. But Prometheus is a major, let's say, collaborator. They also collaborate with us. We collaborate to Prometheus, and we are definitely contributors of Prometheus cTENcf projects. Kubernetes, Grafana, Persis, Gonzo, that blogs, Telegraph, ClickHouse, InfluxDB, and PSQ. We recently celebrated something really cool, $1 billion. That was something that we hit with our products, and also 50K stars on GitHub for VictoriaMetrics. And we are really happy that people are using us and they are very interested in the open source projects. So that's actually something cool. Like I said, since last year, Victoria Logs joined with the same idea for efficiency and scalability as VictoriaMetrics, and VictoriaTraces is under development. Right, and right now I'm just going to pause a second and explain the whole sustainability idea for all the products. So we talked about how VictoriaMetrics was actually created to focus on the optimization for scalability, to address the issues of scalability and efficiency Prometheus has. So when we started to create this, we benchmarked VictoriaMetrics, and we can also look at the benchmarks and run it yourself. So we have like 1.7 less memory, 2.5 less disk space, 60 more like faster query latency, and etc. etc. I mean, the idea is that from the beginning we focused on the hardware reduction and resource efficiency, and that's actually what's going to stay forward in our sustainability mission. Which is really cool because cTENcf is definitely focused on sustainability. Right now, the sustainability tag, that's the technical advisory group, changed into operational resilience. That's just like rebranding of the same idea. But we are taking this very seriously, so probably you should too, right? Right. Talking about the benchmarks. The benchmarks actually are something that we all invite you to run it, to use it. It's not just like made up, numbers. We are actually very, very keen for you to use it and run it in your infrastructure and see how it works. Like I said, we have the blog explaining how we run the benchmarks. You can also test it yourself. This is for VictoriaMetrics. The same for Victoria logs, other numbers that you're going to see here for resource efficiency. Also, we run some benchmarks against like Elasticsearch, MongoDB, and other other time series databases or databases that can be checked at this GitHub repo, ClickHouse, So this is public, so you can all check it. Also with the DuckDB and PostgreSQL, so you can check this as well. And the same for Victoria traces. We are running this. Obviously, once it's production, we're gonna have like more, definite benchmarks for it. One other benchmark we did was with ClickHouse and Grafana Tempo of traces, because Victoria traces uses LogSQL under the hood. So that's the query language that it uses. So it's the same for Victoria logs. So we explained here in full note like how we compared things with ClickHouse and Grafana Tempo. So I'll leave it for you for resources to check it later. And of course, something that I came across, this very cool website, it's open source Insights. It has like a loads of not only databases projects, but everything that's basically on GitHub. So if you want to check how did these projects ranked in the last 20 days, you could go ahead and find out, what's the evolution over time, and if you are interested to see how it is. Right. So here, what I wanted to show you before I get into this part, I wanted to show you like quickly some live playgrounds. Let me check this. Right. Okay, so I'm gonna do it like here, maybe like in a weird way. So I wanted to show you, obviously you have later in the resources, like the links to all the playgrounds, but I wanted to quickly showcase the VictoriaMetrics. This is our user interface VMUI, and here we can explore something that's unique to VictoriaMetrics. It's called the Cardinality Explorer. And here, for example, you can check which metrics will have the highest number of series, basically the metrics that will be the most expensive. Why is this interesting? Because everybody wants to know, about the latency of the metrics, which ones are more expensive, which one takes longer, and everything. So here you can definitely see that you have the top here. So you always want to check the first one that shows up. And in it, you're gonna have the resource, the label name. It's okay, because I like this icon, I can see it. So you can also see the label with the highest number of unique values. What does it mean? It means that, for example, this label here will multiply this query 143 times, right? So in case, imagine like this number is way higher, then maybe you want to rethink dropping the label or anything like that, just to help you in your troubleshooting. And also something that's pretty cool is top queries, which is queries with more summary time to execute. That means the one that takes longer to execute is most latent, has most latency, and will definitely help you troubleshoot your queries, right? Obviously, there are loads of other interesting stuff here that are unique to VictoriaMetrics, like trace analyzer, query analyzer, and all this fancy stuff that I'm not going to go right now into detail, but it's worth checking just Cardinality Explorer, because many SREs, DevOps engineers ask us about, hey, how can I avoid high cardinality? Well, you can do that here in VMUI. Another cool playground is for Victoria logs that you
can I make bigger?
Well, it's already, this is like, sorry. Okay, so yeah, definitely you can check this playground as well and play around it. Obviously, this is, at some point, probably this will all be integrated into one user interface. But it's just for you to explore, and also the traces, like I said, which is right now.
Jana, the query language is proprietary query language, like in VictoriaMetrics type of.
Yeah. So it's developed by VictoriaMetrics.
Okay.
Yeah. For example, the metrics use MetricsQL, but it's backward compatible with PromQL, so the Prometheus query language. And this one for traces and logs is LogsQL. Yeah, full question. Thank you. So anyway, the dashboards also in Grafana, the same, it's a playground. You can check other, like many dashboards here for cluster, for VM agents. So these are like, public. You can play around with it, see how it goes. I'm not going to go into full details here, just to make sure that you see that and we can have fun with it later. So let's see if I can go back here. Right. So yeah, obviously at the point where I wanted to say that I didn't put on purpose here OpenTelemetry as contributing to this OpenTelemetry part, and I'm going to explain why. Well, basically, OpenTelemetry, we have compatibility with OpenTelemetry, and I'm going to explain why. First of all, I wanted to pause here for a second and ask you, like, if you ever used OpenTelemetry or do you know about OpenTelemetry, because I had like conferences that I barely saw like any hands up, so it's always good to check. Cool, that's good. That's really good. I'm not gonna bore you with like a lot of details here. I'm just gonna say that obviously OpenTelemetry is a quite complex CNCF project. That's why it takes. You can see that it was accepted to CNCF in 2019, and it's still on incubating maturity level. And many people are asking what you guys are doing there, like why is not still graduating? Like there's a lot of things to do, right? So a lot of work on the SDKs, a lot of work on semantic conventions. It's a standard, so things will take time, So yeah, we are all patient, and we are all hoping to graduate at some point. But just to highlight very, very brief 2 points, this is how can I say, a framework, right? A toolkit, observability toolkit, and which doesn't have a backend or a frontend, right? No visualization tool or no storage tool, just something that most people tend to forget or they don't know. And that's something important because of the things we'll see later. Right, like I said, VictoriaMetrics does have compatibility, native compatibility with OpenTelemetry. It uses the Victoria logs and VictoriaMetrics, support to ingest metrics and logs. So you can, use it with kubectl or Helm and other Kubernetes clusters. We also forked the OpenTelemetry demo. Like this, it's easier for everyone to understand how the signals of observability work together. And this is what I wanted to show you next. So basically, you go to the GitHub repo and then you can just make build. This will take. So make build actually will take 10-15 minutes. So I'm not going to leave it out, obviously, I wanted to show you that it's incredibly powerful because it needs to download a lot of things on really good. And then you're going to just make start. You'll have all the containers. Then you go to this webpage, which is basically the shop. You add things there to the cards so you can populate, make some events. At some points, you want to go to Grafana. So let's wait for that. I'll just play with it. And have a fast forward. But I'm not going to play the entire thing because I know it's going to be boring at some point. So I wanted to show you Grafana, what you can see with VictoriaMetrics. Right, so I should have put it like on different screen this one. Okay, cool. So yeah, this is the cool part, which is really cool how they made all the Grafana dashboards. Is that you can see here, like we added the VictoriaMetrics data sources. In the original demo, you have the Prometheus data source. So basically, we offer the VictoriaMetrics, Victoria logs data sources, and for Victoria traces, we are using the Jaeger data source. And it's cool because right now our users can go and see like, oh, if I want to use OpenTelemetry, how can I check it? Well, you can check it here. You can see it with all these 3 signals, and once I actually go to the other things, anyway, we have all these topologies span closed, which is really, really cool. Yeah, just bear with me. Just enjoy the graphics.
Just add sound effects next time.
Yeah. So yeah, once this this is the part that basically I wanted to show you. The cool thing is that you can also explore the traces and the logs. And you can see like immediately, so this is like brand new, I ingested like really in the first 5 minutes. And then you could go, once you go down, right, you can see the ingestion of the logs, and find that's exactly like all the steps that you did. So the cool thing about OpenTelemetry demo is that you can see the correlation between the signals, and you can understand like the spans, like the logs and everything, and it's easier for everybody to troubleshoot. For the traces, you can click on the trace ID, and you can see like exactly like the Jaeger, because it uses the Jaeger data source. You can see like all the information there for the services, and yeah, it's something pretty cool to have more details into the distributed tracing, right? So yeah, I'm not going to bore you with the entire this. I went into all the dashboards, and you can have fun too later. What I did want to showcase here is that what I really like about OpenTelemetry is the community. It actually has a very, very active community and a very widespread community. So I got into OpenTelemetry last year, but I started contributing with my first PR at the beginning of this year. And actually, it's something really cool. It's been a journey. I'm not yet tired because I still want to do a lot of things with OpenTelemetry. I wanted to take a moment here to celebrate VictoriaMetrics, and the OpenTelemetry community award that I got from OpenTelemetry community. Is the fact that VictoriaMetrics supported me as an individual contributor from day one, which is really cool. I hope like many other companies will do that, and whatever you find your passion for a specific open source project, you'll have this support from your company. I think that's something really, really nice. And also from the OpenTelemetry side, that I wanted to highlight for you are this couple of, let's say, initiatives or tools, is the OpenTelemetry Weaver and Injector, that are right now focusing on delivering better experience for the developers, right? Better like developer experience. The Weaver is focused on the semantic conventions, trying to make this better for the onboarding of the end users. And also the Injector is actually a tool donated by Splunk. So anyway, you could go more in detail and see what it does for you. It's like basically about auto instrumentation. And so I'm coming back again to the community here. So we are living in Spain. You are wondering like, okay, how can I contribute to OpenTelemetry or other projects? And I think many people don't know that there are the so-called non-code contributions that are available. You can, for example, translate official documentation from English to Spanish and help the community to have its documentation in its native language. This was for me something that I really appreciated when I first started with OpenTelemetry, the fact that the Spanish community is really, really active. And by Spanish community, I also mean Latin community. It's all about the Spanish speakers, basically. And also, this is how I got in touch with Cloud Native Valencia, that I discovered. And later on, I joined Cloud Native Romania, and I opened a special leaders group for localization in Romanian too, meaning to translate the documentation for OpenTelemetry into Romanian, which is my native language. Why this is important? Okay, you think it might be silly, that documentation, who needs it? It's like we all ignore it. It's that dusty thing in the corner that nobody touches, but yet you all need it because when you try to engage with a project, you first need documentation. And if the documentation is crappy, then you're probably not going to understand much. So yeah, this is what we are doing in our free time. So apparently we have a lot of free time. Yes. And then it's about the motivation. I think that's all important once you get started with an open source project to really be motivated. And I know at some point you're going to get stuck. You're going to get bored. You're going to have moments where like, okay, documentation or one or Kepler, one or Prometheus, whatever. What am I doing here? Argo CD, man, I have heard all about that, So it's like, it's important to stay even active, right? It's like going to the gym, stay in the game, be consistent, do the work, show up when nobody else, all that, like do the work. Even if you don't feel like it, just run that PR, man, just like do the translation. So this was, only like true for me. I had to show up in moments when I didn't feel like it. And I also give like this kind of bunch of talks this year about OpenTelemetry. Like people react in different ways. I was like really surprised at some point, like a couple of weeks ago, when this person, called out a bunch of people, including myself, and said, look, just because these people were yapping about their contributions and stuff like this, I decided to do my first one or Argo CD. And that was like pretty cool, So once in a while, once every blue moon, you hit somebody that, actually gets motivated. And I think that was actually also true for myself, because, I got also motivated by other people at my own turn. And I still keep very, very good contact with the community. So I really recommend you to do the same. Right. And for me, it's true about this. Don't get bored with one type of contribution. I'm a code, non-code, wherever you want to take it. And this is not about VictoriaMetrics. You could do VictoriaMetrics as open source, whatever you want to do, whatever open source project you feel like getting involved with. The idea is that you need to diversify your contribution, right? There's going to be a moment in time when you're probably going to need some excitement. So take a look at other projects, speak with other people, understand what's happening, what's new, and get the creative juices flowing. Also pair up and mentor. So in the last couple of months, I've been doing this, and I think it's very important to motivate other people at your own turn. You're gonna have so many good questions in return, and so many like different perspectives that you haven't thought about it, right? So at the moment, I'm in this very tiny group with a organization for me, and I have like a bunch of them that, they're software engineers, and they're doing like this translation stuff. And they're really cool. They have very pertinent questions, and they're really excited and ambitious. So I think this is what, keeps us going, right? To share stories, but not just like stories, just about like very pertinent, relevant stories about that project, right? So this is what I said about share your end user stories. For example, Injector, Weaver, and many other projects, they need end user stories because otherwise we cannot help you, basically, right? So if you don't tell the open source community, the Cloud Native community, what's wrong with something, we cannot help you, right? So we cannot be better indeed. And that's it from my side. We have like all the resources there. And you can definitely find out more about each individual little project and a signal of observability from VictoriaMetrics. We are available definitely as a community on Slack and many other social media channels. If you ever have any questions, also I speak a bunch of languages, we speak a bunch of languages, so thank you for your attention.
Any questions?
Recognition in the OpenTelemetry.
Yeah. Thank you.
Congratulations.
Actually, that is pretty cool because I don't think if they did it last year, I think maybe, I don't know, they thought about it to do it this year. I think it really matters because I think, the community knows that, it's not that we are struggling, but it's a very difficult project to make it graduate, right? And like the amount of people that are contributors that do it in their free time is enormous.
Yeah.
So they also thought maybe like, let's motivate them even further. That's something nice. But it's also about, staying in contact with the community. The idea is that from my side is like a bit sad, but also happy at the same time that I was the only girl woman to be in that list. And I want to say, like, we could, definitely be more involved, be more out there, like with talks, with contributions. Anyway, so we are a community and we could help each other. For me, that was my first KubeCon, and that was a very nice experience because it's indeed a very inclusive and safe space. So this is what we are trying to do here in Cloud Valencia as well, and other meetups, and something that's if at some point any one of you wants to do something like contribution or wants to start something cool, it's nice to keep the conversation going. Thank you.
Thank you, Johnny.